Okay, today we're starting a new chapter, and the new chapter is going to be chapter 6, talking about exponents, rational, when to add, when to subtract, when to multiply, and what all we have to do with those. So a lot of this is going to be review from Algebra 1, so we're just going to jump right in. So here's the rules. For every real number x and the exponents a and b, they cannot be 0. The following is true. If I have a base to two different powers, a and b, then you are going to add those exponents. If I have the same base attached by division with two different exponents, then you are going to subtract them. One base raised to two exponents, you multiply them. Anything raised to the 0 power is always in forever 1. I can have the entire alphabet in there, and it's raised to the 0 power, and it's still going to be 1. Okay? Next, negative exponents. Negative exponents are a big deal. It's the game, should I play or should I go? If it is negative in the top, to make it positive, it goes to the bottom. Just the base with the negative exponent. If the base of the negative exponent is negative in the bottom, then it goes to the top and becomes positive. If I have two bases with different with one exponent on the outside, you are going to distribute that base and that exponent into the base. And is same exact thing here. You are going to distribute. Okay? So now here's an example of each of these so that you can see them. X squared times x cubed, you're going to add those exponents to give you x to the 5th. X to the 5th divided by x cubed, you're going to subtract those exponents to give you x squared. X to the 4th raised to the 3rd power, you're going to multiply them to give you 12. Anything to 0 is 1. Negative x to the negative 7. It's negative in the top, so to make it positive, I have 1 over x to the 7. 1 over x to the negative 9, to make it positive, it becomes x to the 9th. And I have an exponent of 1 on each of these. It's the phantom one, so I'm going to distribute that into it to give me x to the 6th, y to the 6th. This one right here, I'm going to distribute that to both of them to give me x to the 8th, y to the 12th. And the last one, put missing exponents on and distribute to both of those, and you're going to get x to the 12th, y to the 12th. Okay? And that is going to be all your properties with a quick little example of each one of them. Now we're going to jump right in it, and I'm going to show you what I want you to do. Now, if you look at this, every one of these items are attached by multiplication. So what we're going to do is we're going to simply separate them into 3 individual problems. Why 3? Because I have 3 different bases. I have a number base, an x base, and a y base. So I'm going to rewrite this. There's my numbers multiplied together, and here's my x's multiplied together, and here's my y's multiplied together. So we're going to put on our missing exponents, which is going to be on the y there, and then I'm going to straight up multiply here. So this is negative 21. I'm going to add the exponents. This is negative 21, x to the 7th, y to the 6th. This is what I call your piggy bank problem. You dump out all the coins out of your piggy bank and you start sorting them. Quarters with quarters, nickels with nickels, dimes with dimes, and pennies with pennies. That's what we did here. We shook out everything out of the problem. We put our numbers together, our x's together, and our y's together. So this is the piggy bank problem. Now, this problem looks a little bit harder, but it's still the same exact concept. So we're going to look for any exponents on the outside. Do I have any exponents on the outside of this? That's a 1, so therefore I don't. So I really don't even need those parentheses there. However, on the bottom I do. I have to put this 1 on the inside with the 3, and I'm going to multiply those in. So that's 3 to the 3rd, x to the 12th, y to the 9th. Then I'm going to put on my phantom exponent on top, and I'm going to rearrange this to give my x's beside each other, and then my y's beside each other. 3 times 3 times 3 is going to give me, 3 times 3 is 9, times 3 is 27, x to the 12th, y to the 9th. Okay? Then I'm going to go ahead and I'm going to keep going. I'm going to marry these together right here by adding those exponents. So that's going to give me x to the 3rd, y to the 3rd over 27, x to the 12th, y to the 9th. Okay, I'm not done. I have 3 individual problems here. I have the number problem, then I have the x problem, and then I have the y problem. Now, there's multiple ways you can go about this, okay? What I need you to understand is that negative 2 over 27 does not reduce. So immediately I have a fraction. The negative 2 stays on top and the 27 stays on the bottom. The next thing I need your brain to understand is that there are 3 x's on top and there are 12 total x's on the bottom. So if I take away 3 x's from the top, I'm left with none. And if I take away 3 x's from the bottom, I'm left with x to the 9th. There are 3 y's on top and 9 y's on the bottom. So if I cancel out 3 of them in both the top and the bottom, I'm left with 6 down the bottom. So my answer is negative 2 over 27 x to the 9th y to the 6th. Now, let's say I want to do that problem differently, and I'm going to show you what I would do differently. Negative 2 over 27, and then I'm going to subtract my x's. So that's going to be 3 minus 12, and then 3 minus 9. And that stays in the top. So negative 2 over 27, x to the negative 9, y to the negative 6. Then, because the negative exponents are in the top, to make them positive, I'm going to put them down to the bottom, and you get the exact same answer as I have there in the green. I do not care how you do it, as long as you get the right answer. Okay? Next, put this thing over 1. A plus B is one quantity and should be moved together. It has a negative exponent, so therefore, it goes down to the bottom and becomes A plus B quantity cubed. And you are done. Now, tonight's homework is 6-1 worksheet 1, and since I've not been recording for very long, I'm going to go straight into it, and we're going to start tonight's homework. So here we go. Number 2. I need to look at this and say, do I have any powers on the outside of my parentheses? I do not, so this is just a piggy bank problem where we're shaking out the piggy bank and reorganizing. So I'm going to put the numbers with the numbers, I'm going to put the x's with the x's, and I'm going to put the y's with the y's. So now you see you have 3 individual problems. So from there, 2 times 3 is 6. Then I'm going to go ahead and add these exponents on both of them. So that's 6x to the 3rd, y to the 12th. And that is done. Okay? Next, number 4. Same thing. Do I have an exponent on the outside? Yes, I do. So I'm going to look for my phantom exponents on the inside that I'm missing. I'm missing an exponent on the 3, and I'm missing an exponent on the 4. The D has an exponent already, and the E has an exponent already. Now that negative 2 is going to go to every single term inside there by multiplication. So 3 times negative 2 is negative 6, e to the positive 10. And I'm going to extend that bar. When you do that, that is the same thing as extending it up there and understanding that the D and the E are in the numerator. Okay? Now, 3 to the negative 2 is going to go to the bottom and become positive. 4 to the negative 2 is going to go to the top and become positive. D to the 6th is going to go to the bottom and become positive. And E to the 10th stays exactly where it is because it is already positive. So, should I stay or should I go? If it's negative, it goes. If it's positive exponent, it stays. Okay? So now, what is 4 squared? 4 squared is 16, e to the 10th. 3 squared is 9, d to the 6th. And that is your answer. Okay? Let's keep going. Number 6. So do I have any powers on the outside of my parentheses? The answer to that is yes, I do. So that means I'm going to distribute that to give me u to the negative 24 times u to the positive 24. Now, because they are attached by multiplication, I'm going to add those exponents to give me u to the 0. And anything to the 0 power is always and forever 1. Done. Number 12. Now, I have a couple problems here. I have a numerator problem, and then I have a denominator problem. Okay, so we're going to focus on each one of those. So the 25, x to the negative 5, y to the 3rd, there's nothing I can do with that currently. So I'm going to first take care of my denominator. I'm going to do that by putting on my missing powers on my bases inside my denominator's parentheses. So this is going to give me a 5 to the negative 3, x to the negative 6, y to the negative 3. Now from here, you're going to play the game, should I stay or should I go? 25 has a power of 1, so it stays. X to the negative 5 goes to the bottom, and y cubed stays. Go to the bottom now. 5 to the negative 3 is negative, so therefore it goes to the top and becomes positive. X to the negative 6 goes to the top and becomes positive, and then y cubed goes to the top and becomes positive. So now, I have a problem here. I need to rearrange this. So I have 25 times 5, x to the 6th, y cubed times y cubed over x to the 5th. So, if I have 5 quarters in my hand, how much money do I have? I'm going to have 125. X to the 6th. How many total y's are up there? Add them. That gives you 6 over x to the 5th. Now, it looks like I'm almost done, but I still have 2 x's. I have 6 x's up top, and I only have 5 x's on the bottom. So if I cancel those out, what they both have in common, that x goes away, and I'm left with 125 x to the 1st, y to the 6th. And that is done then. Okay? Last one I'm going to do is problem 13. Very first thing you're going to do is put on your missing powers on your bases. So this is 4 to the 1st, y to the 1st, 3 to the 1st, y to the 4th, or y to the 1st. Multiply 4 cubed over y cubed. 3 to the 4th over y to the 4th. Okay? Now, 4 times 4 is 16. Times 4 is going to be 16 times 4, 24, 64, sorry. So that's 64 over y cubed times 3 times 3 is 9, 3 times 3 is 9, 9 times 9 is 81 over y to the 4th. So now you are going to multiply the top numbers together straight up. So I'm going to have 64 times 81, and that's going to give us 5,184 all over the bottom, which is a total of 7 of those total y's, so y to the 7th. And that is how you're going to do tonight's homework over section 6.1. If you have any questions, please let me know.